Hello, today we will be discussing quantum numbers. The first quantum number is n, which is also called the principal quantum number. It represents the average distance of the electron from the nucleus. Therefore, a higher value of n means it's farther from the nucleus and requires more energy to stay in orbit. The values of the n can only be 1, 2, 3, and so on and so forth because they represent the energy levels. The second quantum number is L, which is also called the angular movement quantum number. It represents a subshell. So when L equals 0, it represents the S subshell, which is shaped like a sphere. When L equals 1, it represents the P subshell, which is usually shaped as a dumbbell. When L equals 2, it represents the D subshell, which has so many orientations that the shape of the subshell is obscure, which also goes for F, which is represented by L equals 3. So to determine the value of L, you must base it off of the value of n. So if n equals 2, then L can equal 1 or 0 because the S and P subshells are the only orbitals, subshells, that have an energy level of 2. If n equals 3, then L can only equal 0, 1, or 2 because the S, P, and D subshells are the only subshells with a third energy level. The third quantum number is m sub L, which is the magnetic quantum number. It represents the 3D orientation. It's also determined by L, given by the formula 2L plus 1. So for example, the S subshell has a magnetic quantum number value of 0, which means it can only hold 2 electrons because each orbital can only hold 2 electrons. The P subshell has a magnetic quantum number of -1, 0, or 1, which means it can only hold 6 electrons. The D subshell has a magnetic quantum number of -2, -1, 0, 1, or 2, because it can only hold 10 electrons. And the F subshell has a magnetic quantum value of -3, -2, -1, 0, 1, 2, or 3, which means it can only hold 14 electrons. The last quantum number is m sub S, which is the magnetic spin number. It represents the spin of an electron, and it only has 2 values, which are +1/2 and -1/2. And so for this example, this could possibly be +1/2, and this could be -1/2. So we have 2 example problems, and it says state what is wrong with each set of quantum numbers. So if we look at example 1, we see that n equals 2, L equals 1, m sub L equals 1, and m sub S equals +1/2. If n equals 2, there can only be 2 possible values of L, which are 0 and 1. Whoa! The value of L is 1, so there seems to be nothing wrong there. L also indicates that this is an S subshell, so the only possible value of the magnetic quantum number is 1. Whoa! The value of the magnetic quantum number is 1, and +1/2 is a possible value for the spin number. How tricky! There is nothing wrong with this set. Let's try another example. In the second example, n equals 1, L equals 1, m sub L equals 1, and m sub S equals +1/2. If n equals 1, then the only possible value for L is 0. Oh no! The value of L is 1, so it looks like there's something wrong with the value of the secondary quantum number. The end.